In this video, we are going to talk about even and odd functions. A function that is symmetric with respect to the y-axis, it is called an even function. And to test if something is an even function without having the graph, we can do it algebraically by comparing f of negative x and f of x. If they're equal to each other, then the function is even. So remember in the previous video, we mentioned that to test if something is symmetric with respect to the y-axis, we would substitute negative x with x, and it will result in an equivalent equation. And that's exactly what we're doing here. We're comparing the two equations, one with x, the other one with negative x, as the input. And then a function that is symmetric with respect to the origin, we'll call it an odd function. And to test, to see if a function is odd, we'll do it algebraically by comparing f of negative x with negative f of x. So remember in the previous video, we would substitute negative x for x and negative y for y. And that's exactly what we're doing here. So negative x for x, and this is y, and that's negative y. Let's look at these graphs to see if these functions are even, odd, or neither. First of all, these are all functions because they all pass the vertical line test. To determine if they are symmetric with respect to the y-axis, I can fold along the y-axis, fold the paper along the y-axis to see if the left image coincides with the right image. If I do that for the first graph, the two images will not coincide. So therefore, the first graph is not even because it is not symmetric with respect to the y-axis. Second graph, we'll do the same test. We'll fold along the y-axis here. The left image will coincide with the right image exactly. And therefore, it is symmetric with respect to the y-axis, and therefore, it is an even function. The third graph, even if you fold along the y-axis, there's nothing on the left side of the y-axis, so it can't be symmetric with respect to the y-axis. Therefore, it's not even. Now, let's circle back to see if each of them is odd. To see if a graph is symmetric with respect to the origin, we can turn the graph upside down to see if you get the exact same graph. So in the first graph, if you turn your paper upside down right now, you see that you get the exact same picture. So therefore, this graph is symmetric with respect to the origin, and therefore it is an odd function. The second graph, if you turn it upside down, you get a different image. Therefore, it is not symmetric with respect to the origin, hence is not odd. And the third graph, if you turn it upside down, you're going to get a different image as well. Therefore, it's not symmetric with respect to the origin, and therefore is not an odd function. So at the end, the first graph is odd, second graph is even, and the third graph is neither. Now, what if we don't have a graph? Let's do it algebraically. To determine if the function is even, we'll compare f of negative x with f of x. And if it's odd, we'll compare f of negative x with negative f of x. So let's test to see if it's even. Let's look at f of negative x. That means you substitute negative x in for x, so we have negative 2, then negative x to the fourth power, plus 5 times negative x. Now, negative x to the fourth, that's 4 negative signs multiplied together. 4 negative signs will make a positive sign. So therefore, this is the same as x to the fourth power. And then when you take the absolute value of negative x, that's still the same as the absolute value of x. So we still end up with 5 absolute times the absolute value of x. Now, as you can see, this looks exactly the same as f of x, the original function. Therefore, you can claim that because f of negative x is the same as f of x, this function is even. Is it odd? Now we are going to compare f of negative x with negative f of x. We already have f of negative x, so we just have to calculate negative f of x. Then we'll compare the two. So negative f of x, that's negative, and then f of x is that whole function given to us. Now we will distribute the negative, so we have this will become a positive 2x to the fourth, and then the negative times a positive will give you a negative. Comparing negative f of x, which we just obtained, with f of negative x, which we obtained earlier, you can see that the two are different. Therefore, this function is not odd. It is even only. Let's look at the next example here. Let's see if it's even. First, we'll calculate f of negative x. F of negative x means you substitute negative x for x. So it'll become 4 times negative x cubed minus x now is negative x. Simplify a little more. Now negative x cubed, that's 3 negative signs. Then we'll end up with the negatives. So I'm going to move the negative to the front, and then I have x cubed. And then 2 negatives make a positive x. Comparing this with the original function here, they look completely different. So therefore, this function is not even. Now, let's see if it's odd. All we have to do is calculate negative f of x. That's negative, and f of x is the original function. Now we distribute the negative. So we have negative 4x cubed, and then 2 negatives make a positive x. I'm just distributing the negative here. This time we're comparing, remember, to determine if the function is odd, we're comparing f of negative x with negative f of x. And as you can see, the two equations look exactly the same. So therefore, this function is considered odd. Please note that the only function that is both even and odd is the function f of x is equal to 0. Otherwise, the function can only be even or odd.